Hey, hello. Good evening, Gabriel. That's only you today, right? I almost thought that there's no one coming in, so that's why I left my screen for a while. Sorry for that. Okay. Oh, you got the wrong link. Okay. Anyway, since okay, speaking of you being the only one. Yes, hello, Jella. Good evening. Hey, you guys came in just in time because I was just going to begin. Right, so anyway, let's go to our 9.2. Okay, today we are going to talk about glass and ceramic. Okay, today's lesson is a bit pointless. Today's lesson is a bit pointless. Okay, why do I say so? Because this part is not really coming out in exam. Okay, so today's lesson will be kind of pointless. Okay, I'm not say pointless lah. You still learn something lah. But I will try to go into 9.3 today. Okay, I'll try to go into important parts today. Right, anyway, I'll leave rubber for next week lah, because I don't think we can go there today. Anyway, so let's go to glass and ceramic. As I said last week, Jella, did you receive my video last week? I think I sent it to you, right? If I'm not mistaken. So our alloy is the most important thing. Okay, good. Okay, our alloy is the most important thing in this chapter. All right, but for glass and ceramic, please don't pay attention here because it's not really coming out. Okay, but it's good to learn. So we have two things here, glass and ceramic. They are kind of the same. Because their raw materials are almost the same. Okay, that's why they kind of behave the same way. They are very brittle. You drop your glass, they break. You drop ceramic, they break too. They kind of behave the same way. So as we know, glass is made from silica. Okay, silica. What is silica? Silica, another name for silica is also called silicon dioxide. So where can you find this? You find this in sand. All right, that means inside sand has silica. Silica is also known as silicon dioxide. Okay, so that's the thing you use to make glass. All right, so anyway, here's the thing. Silica, they will melt at very high temperature. To make glass out of sand, you need to melt this thing at 1005 degrees Celsius. All right, so this is why in the Renaissance era, I don't know whether you know this, in the Renaissance era during the 15th, 16th century, around the time of Leonardo da Vinci, glass is actually considered a luxury. Okay, nowadays there are still glass makers in Italy, although it's a dying career okay, it's a dying field. But last time glass are made from hand. Okay, all glass, they are handmade. Only until recently we can make glass using machines. Okay, last time they are all handmade. Right, so this is why glass is considered quite a luxury, because it's very hard to reach this temperature. Right, so about glass, we have 4 types of glass here. Okay, we have 4 types of glass here. Should you memorize them? No, this is not coming out. Even if they do, it's gonna be in objective ABC. You can just tembak your way out of this, because I don't mind. All right, because it's really not worth your point, not worth your time. Okay, I don't want you to spend like hours memorizing this just so you can score that one objective question in exam, because it's pointless. All right, unless you already finished studying everything, you have nothing else to study. Right, anyway, so we have 4 types of glass here. We have fused glass, we have soda lime glass, we have borosilicate glass, we have lead glass. Okay, none of you are taking DM, so I don't need to translate this. So what is fused glass? Okay, as you can see, every glass, silica is the main ingredient. Silica is the main ingredient. Sand is the main ingredient. It's just that when we add different additives, when we add different added stuff, the glass kind of behave in different ways. All right, so let's look at fused glass. As the name says, fuse, I just fuse all the sand together. I just fuse all the melted sand together. So there's only one composition here. There's only one component inside here. That is your silica. Guys, this is the earlier form of glass. You just melt your sand, you melt them together, they will become fused. They will become your fused glass, okay, silica. So the good thing about silica is, the good thing about sand is they are resistant to heat, okay, and they are chemically inert. That means, okay, I'm sure you know the good thing about glass, right? Whatever you put in your glass container, let's say some strong smelling stuff, if you use glass container to put curry, okay, you know curry is very strong. Do you know why curry is so strong? If you have eaten roti canai using your hands, okay, I'm sure for the next few hours, even you wash your hand like a million times, your hand still kind of smells like curry because of the turmeric. Okay, because of the turmeric. So you see, glass have no such problem. You put roti canai or gua or whatever on glass, you can just wash them off, no problem, because they're very chemically inert. Yes, China, hello, good evening. We are in glass, we just started not long. Okay, nice of you to join us. Okay, so fused glass, okay, all glass they are chemically inert. All right, so we use fused glass to make lens and spectacle, but we don't do this anymore. Guys, your glasses they are not made by we call them glasses, okay, but we don't use glass anymore. Why? Because this is very easy to break. Okay, I don't know about you I used to live in a time okay, saying that like I'm some kind of dinosaur or something. Okay, I used to live in a time my friend's glasses last time is made from real glass. Okay, how do I know? Because he play basketball and he drops his glasses and the thing just shatter. Okay, the thing just shatter. So now we don't do this anymore. Okay, we just use, what is this? This is actually Perspex. It's a type of plastic. Why do we use plastic? Because it's more durable and it's more lightweight. Guys, if your glasses, if your spectacle is made from real glass, it's so heavy that your nose will start to hurt if you wear it for like more than 8 hours. Okay, so we don't do this anymore. So fused glass kind of walk into history. So if I'm not mistaken, right? If I'm not mistaken, IKEA bottles like this, right? They are also made from fused glass. Okay, I use a glass bottle, my IKEA glass bottle. Okay, this is also made from fused glass. Okay, because it's cheap. I mean, compared to other glasses, so fused glass, it's strong and it's not that cheap, but it's still cheap. Okay, and it's strong. So that's a fused glass. Right. So if you want a cheaper glass, okay, if you want a cheaper glass, do you know that McDonald's Coca-Cola cup? Okay, you know this? Do you know this? Okay, it was the craze last time. Everyone was trying to collect this thing. Have you seen this before? Have you guys seen this before? You go buy any meal, they will give you one. Okay, it was like what, 10 years ago, okay, because of the World Cup thing. Right, anyway, so this glass, right, since McDonald's, they are giving you for free, do you think they use good quality glass? No, they just use this type of glass. We call it soda lime. This is the cheapest glass, okay, the cheapest glass. Why is it cheap? Because it's very easy to break. All right, so it has low melting point, but the good thing is it's easy to shape. You can shape that into anything you want. That's why the McDonald's cup, they just look like a very fancy shape because they're easy to shape. But the bad thing is they will break very easily. How easy? How easy? You can just break them by using water. What do I mean? All right, if you have this McDonald's cup, right, you can just pour cold water on it. Immediately you add hot water to it, this thing will crack. This thing will just go crack, and then this thing will crack. Okay, ask me how I know, right? So because soda lime glass is very cheap. Okay, hello Sneha, good evening. We are in glass and ceramic. Okay, page 4. Wow, nice of you, nice of y'all to join the class today because last week there was only one. Okay, anyway, so as I was saying, soda lime is the cheapest glass. If you get those free glass from anywhere, it's most likely soda lime. Okay, it's low cost and if you don't mind breaking it, then it's a soda lime. So why do we call it soda lime? Because we add sodium carbonate. This thing is your baking soda. So we add soda to it. That's why we call it soda. So why do we call it lime? because calcium carbonate is what we call limestone. So soda lime glass. Still the main ingredient, for those who just came in, silica is still the main ingredient for glass. Silica is sand. Okay, we use sand to make glass, as we all know. All right, so this is cheap glass, like really cheap. If you don't mind breaking it, if you want to use some kind of glass in your, let's say you're making a movie, okay, you're using glass as your props. So soda lime is the glass you use. Okay, it's really cheap. Anyway, next, borosilicate glass. This is the highest quality glass. If you have this thing called Pyrex, have you seen this brand before? Have you seen this brand before? It's quite expensive. Okay, this is your Pyrex glass. This thing is borosilicate. Okay, they are very strong. They are very different from your soda lime. Like I said, soda lime, right? You pour cold and hot water at one time at once, your glass will break. But borosilicate, they will just be like, yeah, this is nothing. You pour cold water and then you pour hot water, your borosilicate will just chill. No breaking or whatsoever because they are very strong. So this is why we use them for cooking utensil. We also use them for lab apparatus. Your beaker, your measuring cylinder, your pipette, your burette, your conical flask or whatever, they are all made from borosilicate. All right, but guys, your test tube, they are mostly made from soda lime because test tube is very easy to break. Okay, you know the cheap ones lah. Maybe some test tube they will use fused glass. Test tube, boiling tube they will for sure use borosilicate because your boiling tube can last very high temperature. Okay, so you guys get what I'm trying to say here. Okay, and of course, lead crystal, this is not for making any container. This is used to make prism or any refractive stuff because they have very high refractive index. What does it mean by high refractive index? That means they can bend light very well. Okay, what do I mean? So what, sir? If they bend light very well, so what? Diamonds have very high refractive index, even higher than lead glass. So what happens? Diamond can bend light very well, so they will sparkle. Why do diamonds sparkle? Because they have very high refractive index. That's why diamonds, they are so shiny. They have all the bling blings because of high refractive index. So if you have no money to get diamond, I mean, if you were to buy a chandelier, anyone has a chandelier at home? I just find this thing very, very cheesy lah. Okay, chandelier. Do you have this at home? Okay, unless you live in a hotel or something lah. I just find this thing very cheesy lah. Okay, are you like some sort of do you live in some sort of palace or dungeons? No, you don't. So that's why you don't buy chandelier. It's very impractical. Okay, it's so hard to clean. I used to have one in my old home. Okay, in my old house. Okay, it's a nightmare to clean because it will. This thing is a dust trapper. Have fun cleaning it though. So expensive. Yeah, exactly. So this thing, to make my chandelier sparkle, right? To make my chandelier sparkle and go bling bling, I will use lead glass. Okay, I will use lead glass. That's the only thing. So they are not used to make any container. Right, that's it. Okay, that's it. So like I said, please don't focus on this subchapter because it's not coming out for exam. You have my words, it's not coming out. Okay, even if they ask, right? Even if they ask in objective, right? In ABC, right? How will they ask? They will give you these four material. Let's say they will give you silica, boron oxide, sodium oxide, aluminum oxide. They will ask, what is this glass? You see boron, right? Borosilicate lah. If they give you this, you see sodium, soda lime, because calcium carbonate is limestone. You see nothing, fused glass. You see lead glass. That's all. Okay, if you really want to know something, okay, you know their uses. That's all. Just touch and go, guys. I'm not asking you to just ignore this. Okay, you shouldn't. You should, since they put it here, you should at least read a little. So you can just touch and go. Not coming out a lot in exam. Certainly not in paper 2. Almost certainly. Okay, so don't worry. Right, because I hate this part because it's so hard to memorize. Okay, for me last time, okay, I just ignore because it's not worth your time. All right, so since we finished glass, right, let's talk about ceramic. All right, ceramic is a little bit different. They're almost the same, but a little bit different. Okay, so they're also made from very high temperature, same like your sand, but they are made from clay. Okay, you see, sand is made, glass is made from sand. Okay, which is silica. But your ceramic is made from clay. Clay is what we call aluminum silicate. So actually, what's the difference? Guys, do you know what's the difference between sand and clay? Sand is very rough. Okay, if you zoom into sand, right? Okay, if you zoom into sand, right? Sand is very big particle. Okay, sand is very. Why are you showing me this? Okay. Oh yeah, I used to learn this in engineering. There are different types of there. I show this, you understand. You see, sand close up, can you see the big tiny particles? They're really big. And if you look at silt, silt is slightly small. It's much smaller. And then clay is the smallest. Clay is really small. Okay, so one is made from sand, glass is made from sand, but ceramic is made from clay. Okay, more or less the same thing, but it's just that one is transparent, one is not. So ceramic is not transparent, okay, because they're made from clay. And I'm sure your plates, your bowls at home, your cups, they're all made from ceramic, right? I hope so. Guys, do not use plastic bowls or plastic plates or plastic cups. They are not supposed to withstand hot stuff. Okay, if you put hot soup onto a plastic bowl, yikes. Okay, do you want to get cancer? Do you want to get plastic in your food? That's how you do it. So if you, this is why we use ceramic. Okay, the good thing about ceramic is it is very easy to clean. Like I said, like your glass, you put curry on it, you put any strong smelling stuff on it, okay, they will wash away just fine. Okay, have you ever tried washing plastic container, your Tupperware? If your mom used Tupperware to put curry, you finish eating the curry, you wash that Tupperware, oh my god, it's hell. Because even you wash the curry away, the Tupperware still smells like turmeric. Right? Because turmeric is very strong, it will stain every freaking thing. So this is why you use glass or you use ceramic. Because ceramic, they don't stain. Ceramic, they will stay, good condition and shiny for the longest time. If you have ceramic plates at home, I'm sure you have been using it for like 10, 15 years. The thing is still good as new. Yeah, granted there are some scratches on it, but that's all. Okay, it's still good as new, it's still shiny. You see, that's the thing about ceramic, and not to mention it's really cheap. Okay, sometimes when you buy toothpaste, I don't think they do it anymore. Last time when you buy that Dali toothpaste, the Dali toothpaste, they will give free ceramic bowls or plates time to time. Okay, that's when my mom goes crazy. She will for sure get that Dali so that they can give her that free plate. Auntie's favorite pastime is to collect ceramic bowl or ceramic plate and Tupperware. Okay, I don't know whether it's your mom like this. My mom has a very strong affection towards Tupperware. Okay, you don't ever touch a Tupperware though, she will disown your ass. All right, and none, not even once have I ever seen her use those Tupperware. Okay, granted she used a few, but most she just keep it. Just feels like just because she feels like having it. Same goes to ceramic bowls Aunties, they're very very obsessed with this thing one. Okay, anyway, so what's the good thing about ceramic? Okay, number one, they can withstand high temperature. Okay, so that's why we use it to make our tableware, our plates. They are very hard, so we use them to make towels. Okay, see, your towels are ceramic. Okay, your towel is the most long lasting flooring you can use, right? You towel your room, you towel your house, that thing can last for the life of you. Okay, that means if you go to those old house, right? Okay, those towels has been around for 50, 60 years. It's still good. Right? I mean, there are some coming out already, but still good to use. Okay, that's the good thing about ceramic. Right, but the bad thing is it is brittle. Okay, it is brittle, so they will break. So if you drop ceramic, they will just break. They are chemically inert, just like your glass, so they do not rust or corrode. Okay, they are corrosion resistant. That's why we use it as our tableware as well. Even your dentures. If you want to make dentures, you're old, you have no more teeth, you want to make dentures, they are made from ceramic too. All right, and then they are good insulator of heat and electricity. They do not let heat pass through. They do not let electricity pass through. So we use them in our furnace. We use it in our spark plugs. Okay, what the hell is a spark plug? Go ask your dad, he will tell you. You know what's a spark plug? Every once in a while, you need to change your car spark plug. This is the thing that ignites your engine. Okay, this is the part that ignites your engine. Can you see the white color part? The bottom part, the lower half is metal, right? The top white color part, that's the ceramic. Okay, that's the ceramic. Okay, so that's pretty much it. That's our ceramic. Really easy stuff. Okay, so the difference between glass and ceramic. The number one is the appearance. Okay, glass is transparent, but ceramic, they're opaque. That means light cannot go through them. And then melting point, they're almost the same. Okay, both are high. It's just that glass is slightly lower. Can you heat this thing repeatedly? Guys, glass, you can easily reshape them. You can heat them, melt them, and reshape them, but ceramic, unfortunately, no. Okay, you cannot reshape ceramic. You have to recycle this thing. It's not like your glass. All right, so I believe you have no question here. This is very easy stuff. Okay, very easy stuff. Not coming out in exam. So like I said, today's lesson is a little bit pointless. All right. Anyway, so let's go to polymer, shall we? Okay, let's talk something that will come out in the exam. This thing will. Okay, so let's talk about polymer. All right, so what is a polymer? Okay, what is a polymer? Polymer, they are made from monomers. Okay, they are made from monomers. Okay, what do I mean? Monomer, as you see the name mono means single. That means they are one building block. One small building block, the smallest building block, I don't care what building block it is, it's called a monomer. If I put all monomers together in a chain, we call them a polymer. Okay, mono means one. Okay, one. If I chain them together, it's called polymer because I put them in poly, in a huge chain. Okay, you might say, sir, I still don't understand. Okay, very easy. You know glucose, right? You know glucose, right? Glucose is sugar, right? One glucose is a very tiny, simple sugar. When you chain sugar into a long chain, okay, if you have a long chain of glucose, that is what we call starch. So you see, glucose is a monomer, starch is a polymer. I make it long. Okay, you see, this is the simplest Lego. Glucose is one block of Lego. Okay, and then your starch is a long chain of Lego. I mean, if you will, if you will. All right, so very simple here, very simple here. So of course, we have protein as well. Protein is a polymer. Amino acid is the monomer. So you take one amino acid, you chain them together, you get a protein. Same goes to isoprene. We will learn this next week. Isoprene, when you chain it together, you will get rubber. Okay, latex. Okay, latex. So these are natural polymer. Guys, in exam, right, normally they won't ask natural polymer because our focus here would be our synthetic polymer. All right, what is synthetic? Synthetic means man-made. All right, man-made. All right, guys, we only started making man-made polymer in the last 50 years, 50 or 60 years. All right, so man-made polymer, your synthetic polymer, is actually very new. All right, because last time, if you go back to the 1920s, 1930s, if you were to buy a bottle of milk, they have to put it in glass bottle. Okay, they have to put it in glass bottle, and then they started asking themselves. You see, glass is very heavy, glass breaks easily. So, and if you're running a business, guys, if you're running a business, if your bottles are very heavy, you will be wasting a lot of money on transport. Right? Not to mention they will break. You have to be careful. So we humans, we started asking questions. We are like, is there any better material we can use it? Okay, until they found synthetic polymer. They realized that when we take a certain polymer, for example, ethene, okay, what is this? You don't need to care. So if they take something like ethene, this is a type of gas. When I make them into a polymer, when I join them together, this thing becomes polythene. What is polythene? Polythene is PE. PE is the first plastic we found. You see? So you see, when we started discovering plastic, oh my God, it's like we struck gold. Okay, because plastic is cheap to make, like really cheap. They don't break. Okay, I mean, compared to glass at least, okay, they don't break and they're very lightweight. Everything you would want as a manufacturer. If your job is to make milk, you're a milk seller, okay, you're a dairy farm. This plastic is like a godsend to you. Suddenly, wow, we have something so light, so cheap, and so durable. So everybody started using it. So this is why synthetic polymer, these are mostly plastics. Okay, I'm sure you know what is polystyrene. You know it's polystyrene. Some people they call it polystyrene lah. Okay, polystyrene. Our Selangor government banned this lah. But when you buy TV, right? When you buy TV, you buy whatever, they will put a polystyrene around your appliances, right? This thing is very lightweight and it's very good for absorbing shock, so that you don't break your things. Okay, they are also very good for making containers. But unfortunately, or should I say fortunately, because this thing is very hard to recycle. Guys, here's the thing about plastic. These synthetic polymer, yes, they're very good to use, they're very durable, very cheap. But here's the catch. They are impossible to recycle. Impossible. Why? Because they're very expensive to recycle and they are very stable. They are so stable, okay? Plastic is so stable that you put it underground, okay? If you put polystyrene underground, even after 100 or 200 years, this thing will still be there, right? So this is why after we discovered plastic, our global rubbish also start to increase like crazy, because we know that plastic is so cheap, we can just use and throw it away. So we started doing that. Okay, and as we start doing more and more and more of this, we start to create more and more landfills full of plastic. Okay, ask yourself this. You look at your rubbish bin every day. I'm sure you take out your trash, you take your trash out every day, right? You just look inside a plastic bag. How many plastic is inside? I'm sure it's plenty. Okay, your food packaging is plastic. Your many things. Okay, some of your car parts are also plastic. You see, so plastic is something that we cannot run away because it's so cheap to make. But the bad thing is it will remain in your landfill. It is the major source of pollution right now. Okay, so this is why we are looking for alternatives of plastic. We try to make plastic that is biodegradable. But it's not that easy lah. So of course, Perspex. What is Perspex? Perspex is a type of transparent plastic which is used to make your glasses. This is Perspex. This is your Perspex. Okay, so this is your Perspex. We use it to make, aeroplane mirrors, okay, windows for vehicles, and of course your glasses. And these are Perspex. And of course, synthetic rubber, neoprene. We use this to make your diving suit. Diving suit, if you go for scuba diving, you wear that diving suit, right? The thing is neoprene. Okay, so these are the polymers that you should know. Okay, you should know. Of course, these are just a few lah. Do you know there are many types of plastic? Okay, you have your plastic triangle, right? You go to your water bottle, you look at this, you should know. Okay, plastic has like many types, and they have different ways to recycle. You look at your plastic bottles, anything plastic, you will see this triangle, because this triangle tells you how to recycle them. Where are they used? Because different plastic they have different ways to recycle. Okay, as I said just now, our polyethylene, this thing is called our PE, but it's not mentioned here, I think. Okay, and of course we have PVC, we have PP, we have PS. Okay, things like that lah. All right, so you just need to know what's their use. Okay, about the process, this is very simple. To make monomers polymers, Okay, to change monomer into polymer, to chain them together, we polymerize them. You get what I mean? If something has no color, I want to make them to have color, I colorize them. Okay, I colorize them. So to make them into polymer, I polymerize them. Okay, I polymerize them. So this process is called polymerization. Easy? That easy. I polymerize them, polymerization. So to change them back, we call it depolymerization. Okay, it's like when you activate something and then you do the reverse, it's called deactivate. So D lah, and you depolymerize them. Now there you go. Okay, this chapter is a very straightforward chapter. It is what it is. What you see is what you get. It's just like your alloy last week. You know that brass is copper plus zinc. Bronze is copper plus tin. What you see is what you get. Okay, very straightforward. Right. Anyway, so I'm not gonna go too much today lah. Okay, let's go to our exercise. Okay, let's go to our exercise. I will try to do, a little bit more today. Okay, so anyway, I think we did this last week, huh? Okay, we have our copper block here. Okay, I think you did this, some of you did this experiment in school too, right? Provided your teacher is already here lah. So if you put a pure metal like copper here, and then you put a steel ball, you crash a weight onto it, copper will have a very deep dent. Whereas if you use bronze, the dent is smaller. Why? Because bronze is harder. So I don't think I need to show you this, right? What's the MV? MV is the type of block. RV is the diameter of the dent. CV is the weight, mass of the weight. Okay, or the size of the steel ball. Yeah, I'm using back the same steel ball. Okay, I'm gonna skip this. Okay, this is last week's stuff. Right, anyway, list the 4 main types of glass. Okay, we have 4 types of glass here. So we have our fused glass. We have our soda lime glass. Okay, we have our borosilicate. And last, we have our lead crystal glass, or I just call it lead glass. Okay, so 4 types of glasses here. All right, so fun fact, guys, glass is on a hardness scale of 6. Okay, that means you want to scratch glass, it's very hard to scratch. Unless you use a higher hardness thing to scratch it. All right, for example, diamond. Diamond is on a hardness scale of 10. So if you use diamond to scratch glass, you can, because glass is 10. Only a higher hardness can scratch a lower hardness. That's why your screen, your phone screen is glass. Okay, it's a hardness scale of 6. This thing is a 6. So that's why even you use keys, right? You take a key, you try to scratch your screen, you won't do it because key hardness level is 3. Okay, key is made from metal, right? It's made from brass, right? Brass has a hardness level of 3. So 3 cannot scratch a 6. That's why your phone, your house keys, they won't scratch your phone. Okay, not normally anyway. Right, so then you have all these answers here already. Okay, write these yourself here. So component, they all have silica. They all have silica. That's the main thing you have. Borosilicate means they have the boron lah. Okay, they have the boron. Soda lime means they have the sodium hydroxide. Sodium carbonate. Okay, sodium carbonate. And lime is the calcium carbonate. All right, so lead crystal is when they have lead lah. So you know what? Fill this in yourself. They will not ask question like this in exam. Neither will they ask the property. Okay, so please go fill in this yourself. I'm not gonna go into this. You see, this is so boring. Even I start yawning already. Right. Anyway, so number 7, name the major component of glass. Okay, we use silica as the major component. And then B, they already give you answer, silica. Where can silica be found? Okay, they can be found in sand. Okay, passe. Name the elements found in silica. All right, so since silica is silicon dioxide, so you have silicon and oxygen. These two, they are found in your silica. So 3 properties of glass, so many. They can withstand high temperature. Okay, they are chemically inert. That means they won't react with any chemicals. They are transparent, among others. Okay, among the few. Pick your point you want to write. Okay, so next, what is the main component in both glass and ceramic? So that will be a silicon dioxide. They have this thing in ceramic too, although ceramic is mostly your aluminum silicate, more or less the same. So this is the main thing. So number 8, photograph below shows laboratory apparatus made of glass. What type of glass is used? Okay, since this is your apparatus, right, you need strong glass. So we use borosilicate. Okay, borosilicate glass. So B, how is the type of glass selected? Why use this? Okay, because they are chemically inert. They are very stable. They don't react with any chemicals. They don't stain. All right. Have you ever seen a stain measuring cylinder or a stain beaker? No, you don't. They are very clean because they are very strong glass. Right. So C, give examples of another type of glass that may be suitable in producing the above product. So if I don't want to use borosilicate, I want to use a slightly cheaper glass, you would use a fused glass. Okay, fused glass are why? Because they are able to withstand high temperature. Okay, I will not use soda lime because it's too cheap. I will not use lead because lead glass is for refraction. It's for making chandelier. So besides borosilicate, the next best choice would be your fused glass. All right, some manufacturers, they use fused glass for this. You have to look at your brand. You have to look at your brand. If your beaker and your measuring cylinder, your apparatus, if they are branded stuff, then maybe they use borosilicate. But if it is like cheap stuff, maybe they will just use fuse, since you get what you pay for. Okay, so D, is the glass used to make the product above suitable to make drinking water container to be used in restaurants? Okay, yes. Okay, you can use this because they are chemically inert. You can write the same thing. Okay, they will not react with anything. So glass is very easy to clean. So this is why I use glass bottle. Guys, do you know there's a reason? If you want, okay, this is just a suggestion. If you want, use glass bottle. You know why? Because if you use plastic, right? If you use plastic, okay, word of advice here, guys. Word of advice, plastic will do something what we call leaching. Do you know what is leaching? Do you know what is leaching? When you put water in your plastic bottle, some plastic from the bottle will go inside your water. So when you drink your water, you'll be drinking plastic. Okay, not just hot water. You don't think, oh, sir, my mom said don't put hot water in plastic, then I'll be fine. Yeah, generally you will be, but there is still a chance for plastic to go into your water. All right. And as you drink more plastic, it will kill your testosterone. Okay, the hormone that makes you manly, that makes you feel like a man. They will kill your testosterone and they will kill your sperm. All right. So this is why I'm not shitting you, guys. From our grandpa's age, like in the 1950s, until today, scientists has realized there's a constant decline in testosterone. Okay, to translate this into layman's term, men are becoming less manly and they are becoming more girly and gay. Okay, for the lack of a better word, okay, this is why you have seen this thing. You look at celebrities in the 50s, they are praised for their manliness. Okay, but nowadays, if you look at those young celebrities, they are praised for being a pretty boy, basically. Okay, so there's a reason for that because of the plastic in our drinks. Okay, so you continue to do this, it's gonna turn you gay. Okay, yeah, Jella, I know. Hey, you say this, you. I'm not a fan of them, but if you say this in front of girls, they are going to hunt you down. They are going to hunt you down. Okay, you look at girls nowadays, okay. I hope, okay, girls, you tell me, I don't know, girls nowadays, they just like pretty boy bands. Okay, you look at last time, I don't know how to put this, last time in the 1950s, I'm sure when your grandma look at celebrities, if she ever did, okay, she'll look at manly celebrities. Last time when you look at male celebrities, okay, you will know it's a male celebrity because what the fuck else would they be, right? They are manly, they wear suits, they are, good looking, proper male, okay? But if you look at celebrities nowadays, you're like, okay, is that a male or a female? Am I allowed to ask this question? Right? So there's a reason for that, okay? Because our manliness is on a decline. So guys, please cut away plastic from your life if you can. Okay, if you want to go tapao stuff, please bring your own glass container. Do not ever bungkus some kind of soup, soupy hot soup stuff using plastic. This is how you kill your balls. Literally. Okay, you're literally killing your balls and your sperm. So I'm not joking here, guys. Okay, this has been proven. Okay, who knows? 20 more, 30 more, 40 more years later, men will become even more gay. Okay, I mean, there's nothing wrong being gay, but being feminine is the problem. Okay, guys. I mean, if you're born being feminine, then there's nothing to say, lah. But if you are feminine because of pollution, then that is a big problem. Okay, so guys, cut away plastic from your life. Okay, try your. I mean, you see, that's the thing about plastic. We cannot live without them, right? So try your best to change your plastic because I know it's a big nuisance. I know it's a very big trouble. Sir, I go out and tap out. I still need to bring my glass container. I do that. All right, because I don't like my food being on some kind of plastic that I know for sure will be going to my body. All right. Not to mention you get cancer too. You get testicular cancer. Your balls will grow cancer. Okay, so same goes to girls. Okay, not only for boys too. Okay, anyway, so number 9. So you have 2 types here. Ooh, this is a very fancy ceramic. Okay, anyway, so what are the substances used? I don't think I want to answer this question. This is glass and this is ceramic. Okay, what's the most important component? X is your silica. This is made from your silica, and this is made from aluminium silicate. Was it aluminium silicate? Yeah, it was. Okay, sorry, almost forgot that. As you can see, very, very easy peasy stuff. I'm not going to spend time here. Okay. Speaking of Russia, okay, Russian, they are very against homosexual. Do you know that? Okay, being gay in Russia, I feel bad for you if you do. Okay, I feel bad for people who are gay in Russia. They will be, looked down upon like very seriously. Okay, so anyway, so you know what? Oh, this is even a nicer ceramic bowl. Right, anyway, so we skip this we skip this because it's the same question over and over and over again. Okay, I don't think I need to go through this too. Your ceramic and your glass. Glass is used to make your apparatus and your glassware. Okay, whereas a ceramic, you use it to make your bricks and your electrical insulator. Hiya, easy lah. Okay, we skip this. Dazzled by sunlight. She wanted to change the window. If you see sunlight we want glass to solve light problem, we will use a lead glass, the one in your chandelier. Okay, because all these three, they are used to make containers. Right, next 11, let's finish the polymer one. Okay, so a polymer chain is a chain, okay, so it's a chain made of repeated units of monomer. You put many monomer, you get a polymer chain. So there are two types of polymer. You have natural polymer and synthetic polymer, which is here. All right, so what are polymers made by natural thing? So natural is made by natural thing, of course, and then synthetic is man-made. All right, guys, here's the thing. Some of your clothes, they put man-made fiber inside too. Right? Do you know those non-ironing shirt? You know those shirt that you buy from Uniqlo? They say, oh, no need to iron one. Iron-free shirt. That means they already put some plastic inside your shirt. So that plastic will stop your shirt from wrinkling. Because normally our shirt, our t-shirt or whatever shirt, they are mostly made from cotton. Cotton, they will crease very easily. They will wrinkle very easily. So to stop this wrinkling, they will add some plastic inside. So your you know those exercise t-shirt, you know those badminton t-shirt or those football jersey t-shirt. So when you touch it, it feels smooth, right? Because they have plastic inside. They have either PE or PP inside. So those shirt, you can never put them in dryer. If you put them in dryer, they will shrink. Because the plastic will shrink. Right, so natural polymer, what are natural? We have our latex. Okay, we have keratin. What is this thing? Keratin is in your hair. When you dye your hair, right, you are breaking the keratin, so your hair will snap. That's the reason. Same goes to your rebonding. If you go and straighten your hair, the heat and the chemical will make your hair very brittle. So that's the keratin, and of course cellulose. This is your fiber. So plant fiber is a natural polymer. Okay, so this is the thing in your cotton lah. Why can we use cotton to make t-shirt? Because cotton is a polymer. They are made from cellulose. So synthetic, you have your propene, you have your polythene, you have your nylon. What is nylon? Nylon is the thing used to make strings. Your nylon string, you know, the plastic string, it's made from nylon. All right, so really simple here. So what's the process called? Okay, so this is your monomer. This is your polymer. To change monomer to polymer, this is your polymerization. We polymerize this thing, polymerization, and then the reverse is called depolymerization. Hiyo, so easy. Okay, so easy. So you know what? I think I'm gonna stop here. You can go home and okay, there's nothing to do lah. Okay, so next week I shall continue with rubber. I will wrap this chapter up next week, and we might enter chapter 10 because I'm trying to rush your syllabus so that you can go for your final exam. Okay, I believe your final exam should be around the beginning of December, or it should be next year January. Okay, I don't know. All right, so I'm preparing you for this. Okay, we shall do some revision before your exam. Right, so guys, I hope you learned something new today. I know it's kind of pointless, but still you need to know. Right, so I will see you again next week lah. Hope you have a happy Wednesday. Okay, I will see you again soon. Right, so take care everyone. See you next week and good night. Bye-bye.